So there are three scenarios which we are going to discuss as part of this particular webinar. Even before that, let's look into the agenda first. We will start off the agenda discussing about the what are the various types of analytics, why do we need to do predictive analytics, what are the domains where predictive analytics is creating wonders, and finally we'll look into three scenarios where predictive analytics is majorly used. And I'll show you a hands-on which I've performed as part of sentiment analysis, right? Though I'll not be executing the code line by line and explaining you, nevertheless, I'll explain what is sentiment analysis and how we have actually come up with that. So that's a case study use case that you'll be exposed to as part of this session. What are the types of analytics that we have? We have one part which is called as descriptive analytics. What is descriptive analytics? You just describe the data set which is thrown at you. You come up with the measures of central tendency such as mean, median, mode, measures of variance or dispersion, right? As part of that, you look into variance, standard deviation, range, and you look into some kind of graphical analysis. All that is part of your descriptive analytics. After you describe the data set that you have with you, you try to predict the future and you look into how your future is going to behave and take corrective actions in taking due course of correction. Right? That is predictive analytics, predicting on what will be my sales in the future, predicting what will be my profit, predicting on how will my employees' strength grow, predicting on who are those employees who might leave my organization. That's all predictive. The third part or the third stage of analytics is called as prescriptive. I do not just analyze and predict the future. However, I'm also going to provide you with the step of actions, right? Action items on what should be done to ensure that you're on a safe zone. So this is how you traverse the path. So here we have advanced and emerging analytic capabilities. If you see here the percentage, 70% is descriptive. What does descriptive mean? We just analyze, we take the data and analyze on what has happened, right? Only 30% of the times we actually analyze and try to answer this question on why did it happen, right? This is called as getting to the root cause, basically. What will happen if you're coming to the future? This is all about the present. You take the data, whatever has happened until now, you analyze the data on what has happened, and you try to find out the root cause on why did it happen. However, if you move to the predictive zone, or if you move from the present to the future, you see these two components there in the future. Predictive, what will happen, right? That is predicting the future. Only 16% of the entire globe actually uses this capability, right? Customers across the globe, clients use only 16% or 16% of your entire market, which is into business, uses this predictive analytics. The last thing is prescriptive. Look at this. Here is where you have a lot of potential. If you're looking into shifting your careers, then I would say look into this percentage. There's still a lot of opportunity for you guys to explore and actually flourish well there. 3% only are looking into what should we do in the future. Normally what happens once you get to know what is your prediction, this information is given to some kind of a strategist or strategy and operations person who is from a nice B school. He's going to analyze and come up with the next steps of action. However, can we come up with a model which also suggests on what are the steps that need to be taken? That is the way we are moving forward, right? That's the next generation of analytics all about. And not just giving the solution, giving the best solution given the constraints. That is called as optimizing. Prescriptive, being prescriptive or coming up with prescriptive model is nothing but coming up with the best solution. not just the solution, but the best solution, right? And in the current world, you have a lot of business applications, and from those business applications, you're getting the data using which you're coming up with your analytics, using which you're coming up with your forecasting, prediction, and all that. However, the way the world is moving forward, we will see that analytics would become or would take the center stage, and all of your business applications will be built based on your analytical capabilities so that you reap maximum benefits. No matter how many business applications I have, what if I cannot analyze the data? How good is that data, right? Hence, look into your analytical capabilities and build your business applications so that your profits or whatever results you have are multifold. What are the industries it's applicable in? We are coming to that in a while. So what is predictive analytics? Predictive analytics is all about using your data which you have, the data which your company generates as part of using enterprise resource planning, ERP applications, or any of your company applications which generate structured data, and also looking into the unstructured data, meaning the data which is getting generated on Amazon reviews, on your social media, Facebook, Twitter, etc., the images that you're uploading, the videos that you're uploading, the signal processing which is happening, your GPS system, your Wi-Fi's, everything is generating data. However, this data, which I've spoken of late, right, is unstructured data. So predictive analytics is all about taking structured and unstructured data and also semi-structured data, and then use some kind of statistical algorithms and machine learning techniques. This is becoming the norm, machine learning, right? I believe Edureka has a separate course on machine learning, decision tree. Okay, so using statistical algorithms and machine learning techniques, you look into what is the probability that a particular event might happen in the future. That is your predictive analytics all about, right? You can use this for looking into consumer behavior. Who are the consumers who enter into my store on every weekend but do not purchase anything? Probably that's important for me. Why are they coming? Are they coming for window shopping or shoplifting, or what is your objective? Or who is that consumer who comes once in a month, probably in the first week of every month, and does a purchase of worth 15,000 rupees? I want to provide him special discount probably. Then you have machine learning. If you think about Google car, driverless Google car, this particular mission has started long back. However, it's still not live. The reason being, it's still learning. That algorithm is learning on what do I do if there is a left turn? What should be the radius of the steering? What should I do if there is a pothole? What do I do if pedestrians are crossing the road across zebra crossing? What do I do if there's a red signal? Right? It learns. Your algorithm learns as and how you progress. Right? And this Google car is being exposed to variety of roads in variety of traffic situations, right? On highways, on in lanes where there are a lot of speed breakers, toll gates, and all that, so that the car learns, algorithm becomes so much so robust, and then we can actually launch that particular car in the market, recognizing the various patterns. If you upload your image on Facebook, not your image, say your image along with your friends, a group of friends. The moment you upload, Facebook is going to quickly scan and check those images with all of your friend images, and it's going to automatically tag a name against your friend's photo. That's called as pattern match. Scoring, visualization, predictive, so on and so forth, right? So let us move on and try to understand what is a life cycle of a predictive analytics project, basically. So first comes first, what is a preliminary step? Identify or formulate the problem. What is your problem? If you go wrong in this step, no matter how robust your application might be, how robust your predictive prediction results might be, how robust your prediction model might be, it's of no use, right? So you spend significant amount of time in identifying what is the business problem that you're trying to address as part of your project. Then you prepare your data. Here is where you spend a lot of time cleansing your data, wrangling your data, bringing your data from semi-structured and unstructured to some kind of a structure. Then you do EDA, exploratory data analysis, elementary analysis. Then you try to transform the data. I mean, this is again advanced concept on if data is not normal, what do you do and things like that. Then you build a model based on your data type, right? Either you end up using some kind of a regression technique, logistic regression, or some kind of data mining technique, what it would be. Once you build the model, you need to validate and check what is the accuracy of the model. If you feel that the model is very accurate, or if you feel that the model is satisfying your business requirements, then you deploy it. When I say deploy, you're going to use this prediction model to predict your future. Whatever future your prediction model is predicting, you should have some kind of confidence on that. Hence, you validate the model, look into the accuracy of the model, etc. And then finally, whatever outcome your model is going to give you, you're going to evaluate those results and monitor those results on an ongoing basis. Normally, in the current world, I did not see, I mean, maybe in the large projects it might be prevalent. However, I haven't seen a situation wherein there will be a different business analyst, a different data miner or statistician, a different IT systems management guy, and a business manager, right? Most often than not, all these four roles are performed by a data scientist. That is a kind of market which we are looking at. Here we go. So someone was asking on what are the various industries it's applicable, and it's applicable in a lot of industries. And here are a few advantages of using your predictive analytics. One is campaign management. What does that mean? Suppose you're promoting your product, or say you're sending a particular email to a person. Did that person even open the email? Or say you have sent email to 1,000 folks. Out of 1,000 people, how many people have actually seen your email, and how many people have acted on your email? Right, that's most important. And how do you effectively manage your campaign? It should not so happen that I send email, if it's an email campaign, it should not so happen that I send email to all 10,000 of my customers. Right? If few of your customers see email every now and then, probably they'll spam it. So we have to be extremely cautious and careful on how many emails are being sent, what kind of emails, what improves the efficiency of the conversion, right? If you're sending say Samsung phone email marketing campaign, how many of them have actually purchased? So all that is something which you can analyze even before you send an email. Customer acquisition. How do you acquire the various customers? Right, you actually gather all the data on what is the age of a person, gender, income, geographic location, married or not. You collect all this information, and based on this, based on your historical data, you actually say that, hey, this person who is a male, who is 33 years age, who is married, who has 2 kids, whose income is so much, would most likely purchase a product. Right, so you actually end up using historical information, and then based on that historical information, you try to predict on who are those customers who might most likely get converted, whom you can actually acquire. Budgeting and forecasting on whether there will be a rain or not, forecasting on whether there will be a flood or not, forecasting on how many 100 rupee note I have to mint, how many 500 rupee note do I need to mint, right? Forecasting what will be the GDP of the nation, right? What will be the inflation, what will be the interest rate. So all this is forecasting basically. Fraud detection. If I lend a loan, if I give a loan to a person, Will that person default or not? Should I even approve the loan in the first place? The moment a person applies for a loan, should I even approve a loan or not? Right? If you're making a number of transactions using your credit card, which of those transactions is fraudulent transaction? You actually get a call from the call center, right? Sometimes you get a call from the call center the moment you swipe your credit card, and they ask on whether that's a valid transaction or not. Do they call you for each and every transaction? Do they call you only for the high value transaction? No, it is based on some algorithm where you are swiping that card, right? For how much amount, at what time, right? Based on all these things, this information is received. Promotion. Say I've got an email promoting Samsung. I've also seen that particular advertisement on a newspaper. While I was reading the newspaper, I had my news channel on and there was an ad on the TV which said iPhone S6 Edge, all right? And while I was trying to, you know, board my flight, I have seen an ad there, right? And hence I've gone to a store and purchased Samsung S6. Now, which of your promotions has actually triggered me go and purchase Samsung? Was it the newspaper ad? Was it the email ad? Was it the television ad? Was it the ad that I've seen in airport? Which ad actually triggered me? That's the most important thing. Your analytics will help you decide on which is that ad which has forced this person to actually purchase. Or was it combination of multiple ads which has triggered the drive to go and purchase Samsung S6, right? Pricing. What should be the price of Apple iPhone 6s or 6s Plus, right? By how much should I slash the prices of iPhone 6 and 6 Plus, or by how much should I slash the price of iPhone 5 just because I'm about to launch iPhone 6 Plus? If I slash too much, my old customers would be upset. If I do not slash, the sales of my iPhone 6 Plus would not increase. What should that appropriate price be, right? Wherein there will be a right balance. And that is all about predictive analytics. Demand planning. Think about your logistics company. Think about FedEx or whatever be it. How many stores do I need to have here in India? In which states, how many do I need to have, right? What is the pace at which urbanization is enhancing? Urbanization is happening. What is the pace at which people are ordering or parceling the goods using FedEx? Based on all these things, a new branch should be open. It's not open just because there are a lot of people here. No. It looks into a number of other parameters. What kind of goods are being ordered? From which location? Right? What is your duty fee on that? Are you really making profits or not by delivering or by opening a new branch, right? Even before I open a new branch of FedEx, I'll analyze all these things. Think about oil company, oil and gas. The moment you drill oil and gas, right, no doubt all that analysis would be done based on your um, geologist and all that who's going to tell you that, hey, drill here so that I get oil. No doubt about that. But your predictive analytics will say, how many wells do you need to have, right? How deep should you drill? Should you do a horizontal drill or a vertical drill, right? From there, when you extract crude oil, how do I transport it back to the factory? Should I transport using ship? Should I transport using road? Or how do I actually transport? What is that which is going to help me get maximum benefits? All right, Abhishek has this question, is predictive analytics related to data mining? Absolutely. Data mining is one aspect of predictive analytics, Abhishek. And machine learning. In the initial few slides, I've discussed about machine learning. Machine learning is nothing but your data mining, right? So I think I've answered Anurag's question. However, there are a few more slides, I believe, on industries. Why predictive analytics? Because let me give you an example of Target. How many of you all know Target? Target is a big retail firm, right? In US. They have lost approximately $8 billion just because they have launched a new store in Canada. $8 billion. What if you could have done some kind of predictive analytics and check on whether the new store that you're going to launch in Canada will make profits or not? What if you had done that? You would have saved $8 billion, right? Hence, you have to get, or each and every company will move towards that zone eventually. Most of them have done, a few of them will do eventually. So, Nirav Kumar has this question: what are the issues in predictive analytics for big data? So, the main challenge is that to bring your big data into a structured format. And another problem is that which system or what should be the computing speed of your machine to manage the big data. Hence, there is a concept called as population and sample, wherein you just take a subset of the big data and build your predictive model on top of that. Your entire statistics is based on this population sample concept, right? So you should not really be worried about how big the data is. You should be worried about what are the variety of places from where you're getting the data. Right? From big data perspective, look into the variety wherein you get a video file, an audio file, an image, a text file, and how to analyze all that, how to bring that to a structured format. That is where your challenge lies. Once you bring it to a structured format, it's just click of a button, right? I mean, it's not going to take a lot of time for you to build a model. So this is what your Forbes has to say. The top objective for between 2/3 and 3/4 of executives is to develop the ability to model and predict behaviors to the point where individual decisions can be made in real time. Tomorrow, if you want to invest in the real share market, what happens? Your mutual fund broker might call you, or your stockbroker might call you and say, hey, sir, can you please purchase this share? In the next 15 minutes, we foresee that it's going to increase by 5% or 2% or whatever be it, right? So that's the kind of behavior that we are looking at. The moment you enter a store, I should be able to track you based on your GPS system, and then I need to look into your past purchasing behavior and send you a coupon saying that, all right, you're in my store now. There's a special 10% discount for you. Go purchase your favorite denim jeans. Real time, as and how you cross. Say you're going to office on a daily basis, right? From point A to point B. And online, you have searched today for MacBook Pro, for example, Apple MacBook Pro. You want a laptop? So you have just done that search. Tomorrow, while you start from your home and on the way to your office, if there is any store which is going to sell MacBook, they're going to send you an SMS. Even before you approach that store, even if before you cross that store, they're going to send you an SMS saying that, hey, there is a store here which is going to sell MacBook Pro, right? And it's 500 meters away from the place that you're driving. What else do I want to make my life more easy? There are a lot of companies which have started, implementing predictive analytics, and they have reaped the benefits in a very big way. Best Buy, right? Olive Green, RSC. It can be applied across all these domains. If you see trading, what will be the share market? What will be the share value? At what price do I need to sell? At what price do I need to, buy? So on and so forth. Banking. Should I even provide a credit card? Should I approve a credit card? Should I approve a loan? Will that person default or not? E-commerce. A person who purchases this will also purchase something else, right? How do I decide upon that? Dating. Based on your behavior, based on your age, gender, the location that you're in, your dating websites are going to suggest you a few people with whom you can date, so on and so forth, right? So it's applied across these industries. Jnaneshwar has this question on what is the difference between machine learning and statistical algorithm. Your statistical algorithm, Jnaneshwar, okay, if others do not understand the technical aspects, forget that. Statistical analysis means I try to build some kind of a regression, some kind of a model which is based on regression. For example, I can use linear regression or logistic or Poisson regression or negative binomial or binomial or Weibull or whatever be it, right? I do some kind of a regression. I will be predicting until then. However, when it comes to your machine learning techniques, take example of your Gmail. The moment a mail comes to your inbox or mail comes to your Gmail, it gets classified as either spam or it goes and enters your inbox. How is that decided? Can I do a one-time activity on that? No. It's an ongoing activity. Each and every time a new email is received, and each and every time you mark a specific email as spam, right? Your machine is learning, your algorithm is learning there. Suppose I get a travel related email. I select that and click on mark as spam. What happens? The next time any such email, similar kind of email automatically goes to my spam. That is called as teaching your algorithm. Your algorithm learns over a period of time. However, in statistical analysis, you just implement that. However, you improve the model at a later point of time once you collect sufficient data, but it's not real time. Here in machine learning, it's real time. That's the difference. Dharmender has this questions. How machine learning is changing data analytics and why someone should use machine learning instead of legacy data mining techniques? I do not understand the difference between legacy data mining techniques and the advanced data mining techniques. Data mining is a topic and the topics are getting enhanced, no doubt about that. So earlier it was neural networks, then came SVM, right? Sorry, SVD and sorry, SVM, my bad. And now neural network is again trying to come up with some advanced techniques which would supersede your SVM, so on and so forth. So they're building upon each and every topic. So there's nothing called as legacy. Whatever data mining techniques which we are using as of now is advanced only. Machine data mining is nothing but machine learning, Dharmendra. Within data mining, you have supervised and unsupervised learning, all right? And most often than not, we relate this term machine learning to supervised data mining techniques. Anurag has this question, is it related to CRM as well? If it's customer relationship management, in some extent, to some extent, yes, it is related, right? Not to a great extent, but to some extent it is related. Whether all company using social media for predictive analysis directly or they collect data from social media to local storage. Nirav has this question, whether all company using social media for predictive analytics directly or they collect the data. So what happens, you can use a lot of connectors or some kind of applications which are going to link your social media to your analytics tool. Yeah, it's an ongoing thing. In, in a few companies, they actually extract the data from the social media and do the analysis. In few other companies, they directly establish a relationship. So there will be some kind of intermediate tools which will establish the link between the social media and your tool, which will continuously dynamically keep doing the analysis. Mayank has this question, being a .NET developer, what are the prerequisites to start learning predictive analytics? So since you are a .NET developer, I would say that you have an additional edge in using analytical tools, which requires some amount of coding. However, you need to know statistics, you need to know forecasting, you need to know data mining techniques in order to, you know, uh, do a proper shift from being a .NET developer to a data scientist. So I'll take a few of your questions in a while. Let us first try to look into the three scenarios where predictive analytics is used. The first scenario that we are going to cover for today is called as churn. Churn means, say today I'm using Airtel network, tomorrow I might move to Vodafone. That's called as churn. So today I'm employee of company A, tomorrow I might quit the company and move to company B. That's called as churn, attrition basically, right? When your customers reduce their usage or completely stop using your products or services, what's happening? They are leaving your brand and might be shopping with your competitor. This is one indication, right? There's a customer who is not using the internet. There is no usage since 1 month or so. Or there's a person who used to always purchase Levi's jeans. right? Once in a quarter or so. Now he stopped purchasing. These are all the indications for you which say that customer is moving on. He's trying to go to a different provider, competitor, right? And the cost of acquiring a new customer is extremely high, right? So let us first understand this. Most important reasons for doing churn analysis. First one is reduce marketing cost. I don't want to send new promotional email to acquire new customers at the expense of losing my existing customers. The cost of retaining my existing customer is way below, way low in comparison to acquiring a new customer. The amount that I'm going to spend on marketing for acquiring a new customer is extremely high in comparison to satisfying my existing customers. So that's one reason on why churn analysis is so important. You reduce churn through predictive models. If your predictive model says, hey, this person A might leave our company, he might resign in the next 3 months or in the next 2 months. If a person actually sends a resignation email and then if you sit with him and try to convince, it might not be fruitful. However, even before he resigns, before he sends a resignation email, if you go have a chat, discuss, and try to satisfy his requirements, probably chances are high that you might retain him or her. Segment market into alike clusters as per their profits. You can do some kind of clustering. Say this is your entire customer base. You can say that, hey, out of so much of customer base, these are the top profit making customers. So probably I do not want to lose them at any cost. I will do churn analysis only for these customers. Rest of the customers are less profit making. So I probably do not want to do any kind of um, what do you call churn analysis, right? So you can do all these kind of things, right? Understand customers and their behaviors, right? Only and only if you understand the customers and their behaviors, you'll be able to arrest the churn. And you know for a fact that each customer who is gone means profit is gone for you. Each customer that you lose, along with him, you lose some dollars. So you're losing your profitability. Cost of acquiring new customer is much higher than retaining existing customers. This is the most important thing, right? You have to convince the new customers, but if you have an existing customer, you need not convince to such an extent. If you just send an appropriate offer, probably he'll stick with you. And not just losing that customer, right? You don't just lose an existing customer, you also lose the referrals along with those customers. This customer, if he was with you, probably he would have referred your product to 10 other customers. So you did not actually lose one. You have lost 10 customers. In that sense, churn analysis is extremely important. Why do you want to predict churn? Because otherwise your profits would shrink because your number of customers would shrink. And your social media sentiment, people who are dissatisfied with your product nowadays are going to spread word like wildfire. They're going to post about your product, whatever is wrong, in the social media, left, right, and center. That's only going to harm you. It's going to shrink your profits once again. It's going to increase the competitor market share. It's even more dangerous. If people stop purchasing iPhone and start purchasing Samsung to a great extent, then what's happening? You're killing Apple, right? Customer service requests are going to increase. So these are all the various reasons why it makes sense for us to predict the churn. And customer retention. You want to retain the customer. Cross and upsell means people who purchase iPhone probably want to purchase iPad. You can sell them iPad. People who purchase iPad probably you can sell MacBook Pro, so on and so forth. You'll be able to predict their behavior and when a person might want to leave, so on and so forth. So these are all the bunch of advantages that you have if you predict your churn. Cost to acquire a new customer is 5 times higher than retaining the existing customer. And remember, your top 30 of the existing customers comprise 100 to 150% of your profitability. So what if customers are leaving from this top 30%. It's even more dangerous. And we know for a fact that 10% to 10%, 10 to 20% churn annually is a norm in the industry, right? Given the kind of competition that we are seeing. And if you have a higher churn rate, it's going to impact your growth. And if you feel that, let my customers go, I'm going to acquire the new customers. It's a wrong strategy. You are not going to survive as a business if that happens. And this is your churn prediction landscape. So what we can do about it, first thing is identify who are the customers who are churning, evaluate and try to find out what is the churn rate, measure your financial loss, and monitor how is it trending. How is your churn rate, whether it's increasing or decreasing or staying constant or whatever be it. So what you have to do is you have to come up with the churn likelihood and probability matrix. I'll not be doing a deep dive into these things, right? We'll do a deep dive in the next case study given the time, right? There's very less amount of time left. So say the churn rate was so much in Jan, right? And then you try to do some kind of analysis and probably your churn might be stabilized after a few days or after a few months. That is what this entire churn likelihood and probability matrix is. Rather than spend time here, let us actually spend time on the real case study that I have in the interest of time, and that is sentiment analysis, right? What is sentiment analysis? A person might speak about my product on different forums. What if a person opts Amazon reviews? Amazon reviews are, by the way, extremely active forums. So if a person goes to Amazon reviews and starts writing few review comments about my product, and what if that turns out to be a negative review? I need to be in a situation to act upon that. If a person is writing something positive, then also I need to analyze because I need to know what is my strength. What are the features that I need to retain in my next release? Say there is iPhone 6 and Apple has come up with iPhone 6s, right? So Apple might have done this analysis on what are the features which people are extremely happy about in iPhone 6s. They want to retain those features. And what are those features which customers are unhappy about iPhone 6? I want to get rid of those features in iPhone 6s probably, right? In those kind of places, this sentiment analysis makes a lot of sense. So let me show you one such small example. Suppose you go to Amazon, right? And you want to look into the Amazon Xbox reviews. It will be in this format. Though I have captured only a few of those. You'll see